Hi everyone, my name is Shumo. I'm the founder of NEBRA. Let me introduce you what we're building right now. So in NEBRA, we're building the shared settlement layer for the future internet. So let's get started. So we're gonna talk about proofs, right? Why we need proofs from the first place. I think the question need to be asked, why we need blockchains in the first place? In my view, blockchain is a human coordination technologies. So because we have blockchain, we can getting rid of the friction of coordinations. So we can better coordinate. And this is a famous meme I actually get from David Hoffman. So you can see here, ZK cryptographic or blockchain technology is kind of in the Trojan horse. The fundamental goal here is to replace the old institution with newer institutions and with better institutions. So in our view, proof is going to power the next 10 years of Ethereum. So we have various kind of application of the proofs, from the scaling, for example, ZK EVM and different kinds of ZK VMs like Scroll, ZK Sync, Polygon, Linear. I have always had problem of pronouncing their names, but they are a great project, and also Restero. And also proofs is inevitably power the privacy preserving applications. For example, like Somaphore, Macy, Aztec, and actually very few people know WorldCoin are generating a lot of proofs because they are privacy preserving DID, where basically prove you are a unique human and without revealing your identities. And we have some people call it oracles, some people call it coprocessors. But we have all these ZK-based oracles like ZK Brevis, Lagrange, and a few others. So the fundamental question we ask is that what would prevent us to bring more proof on chain? So today I'm going to talk about NEBRA. Basically, can make your proof on chain much cheaper, and also we can bring shared settlement layer to Ethereum. So in this talk, first I'm going to talk about NEBRA UPA, which is the universal proof aggregator we have been built. And next, I'm going to show you how can we build a shared settlement layer using NEBRA UPA. Let's get started. So at NEBRA, we identify the biggest problem to prove singularity is the verification cost is very high. So this is an overview of how much US dollar you need to spend to verify a single zero-knowledge proof on chain, and in this case on layer 1 Ethereum. You can see a single gross-18 proof costs about like more than $20, and it's also based on the 30 GWA gas fees and 3,000 USD each price. And you can see these two factors are purely multiplicative in the sense that can be easily go up to $100 in this year. I'm not totally surprised. And a single Halo 2 KZG proof costs about like 36 US dollars, and the Stark proof costs more. I think Vitalik has been famous said, do you want to pay $20 to add privacy for your transaction to buy a coffee? Maybe not, right? I think then the next question is how can we solve the problem? So that's why we built NEBRA UPA. In a very simple sentence, how can we make ZK cheaper on chain? The short answer is using ZK itself, right? What do I mean that? So in NEBRA UPA, we build a recursive proof verifier in the sense that we can aggregate proofs from different circuits. That's why it's universal, which means we are aggregating proof, for example, coming from ZK rollup, ZK VM, privacy preserving DIDs, and many others. And from NEBRA UPA, we can generate a recursive proof that aggregate all this proof into a single proof. As a result, we only need to verify the aggregated proof on chain. And the cost of verifying an aggregated proof is roughly the same as aggregating each of the individual proof. Because we still need to do a bit of other things like Merkle storage and a few other things, right? So it's not exactly the amortization of each single proof, but pretty close. So from a high level, this is a NEBRA UPA protocol. First, NEBRA UPA is an on-chain smart contract, which means it's permissionless. Like anyone can interact with us as long as you pay us like ETH as a native gas tokens. And second, it's a censorship resistance. So NEBRA design is actually very similar to L2 in the sense that we have a forced inclusion mechanism so that even ourselves cannot censor you, otherwise we'll be slashed. And last but not the least is that we are progressively decentralizable. Currently, we are running a distributed prover backend, and in the future, we will decentralize ourselves. These are the high-level overview of the NEBRA UPA protocol. And also using NEBRA UPA is extremely simple. On the left-hand side is how would you verify a zero-knowledge proof on-chain today. So let's say if you have a ZK application client, the application client generates zero-knowledge proof, and then you submit a proof to Ethereum or EVM chains. Usually you write something like a verifier.sol, which is a verifier contract that calls elliptic curve operations like pairing and elliptic curve additions. These precompiles. And using NEBRA is pretty much the same. The only difference here is that before you submit proof to NEBRA, you need to register your verification key. And then after that, you still, on your ZK application side, you generate a proof, you submit to our smart contract. It's a fixed address among different EVM chains like Ethereum, different L2s. And then we handle the proof aggregation for you. Then we submit the aggregated proof on chain. Then you get a notification, hey, your proof is getting verified. Let's dive a little bit deeper to NEBRA UPA 1.0, which is launched 2 weeks ago in testnet. So NEBRA UPA 2.0 on the proof aggregations circuit, we built ourselves using a 2+ layer of recursion using Halo 2 KZG. We chose Halo 2 KZG for its best non-native arithmetic performance, and we actually built our own non-native arithmetic circuit. So Underhood on the backend side is powered by a pipeline and distributed prover serving architecture, and I will show you more in the next 2 slides. Last but not least, it leverages GPU accelerations to bring down the latency and improve the performance. So let's dive down a little bit deeper in the NEBRA's approver backend. First, we have a 2-layered Halo 2 KZG circuit. It consists of a 2-layer circuit. The first layer consists of 2 kinds of circuit. One we call the UBV, which is a universal batch verification circuit. You can see this is basically layering about 10 Grosseking verifiers, but this is a universal Grosseking verifiers. Last, we have a catch-X circuit, which is a universal catch-X circuit that handle public input, and we can handle public input of various size. And then we using a Halo 2 KZG aggregation circuit to aggregate these 5 proofs. It's distributed because each single circuit, we're using a dedicated GPU prover to prove it, in the sense that it's embarrassingly parallelizable, which means all these circuits are proving at the same time with different machines, unless there is a data dependency. Using distributed proving, we can dramatically improve the prover backend time for a single batch, which means our current proving time of a single batch is less than 2 minutes, which is very close to Ethereum layer 1 like block time if you consider real. So we don't need an external service, or we don't need trusted third parties to verify the proof. Secondly, we actually overlap improving over batches, which means whenever the first batch comes, our coordinator will spawn the prover cluster 1. And while the prover cluster 1 is still working, well, if at the same time a proof batch 2 comps, our coordinator will spawn another prover cluster. We call it the prover cluster 2, so on and so forth. Which means we don't have to wait for the prover backend proving the first batch to start the second batch, and this greatly improve throughput. As a result, NEBRA UPA 1.0 is extremely performant. In last December, we did a stress test of our system. We actually aggregate more than 1 million proof over 36 hours in Sepolia. And by the way, as a side effect, we have burned like 3.5K Sepolia ETH. So this basically registered a 10 proof per second throughput. And you can view the experimental result on chain in this Sepolia scale link, right? So this is much, much greater than the current demand of all the proofs verified on Ethereum and all the L2s combined. And we're also working very hard building the NEBRA UPA 2.0. And here is a sneak peek of NEBRA UPA 2.0. NEBRA UPA 2.0 will support proof aggregation from proofs coming from multiple proof systems. So not just Gross-16, and also Planck, different variation Planck, like a Flunk, Halo 2 KZG, and also Stark. So the idea here is that instead of building a universal verifier circuit, we're building a proof aggregation virtual machine. And these virtual machines leverage the newest cryptographic advancements, for example, fast recursion using either folding or Stark-based continuation, and also cycling curves for even less non-native arithmetics, and more efficient polynomial commitment scheme designed for optimized recursion overhead. And of course, more efficient lookup argument schemes to further accelerate the non-native arithmetics. That's about NEBRA UPA 2.0. So that's all about NEBRA UPA. You can say it's an extremely powerful protocol that can greatly reduce the ZK verification cost and can also let you compose different proofs together. So my analogy here is that NEBRA UPA, if you are familiar with the space analogy, is a rocket engine, right? But it's not the rocket yet. So what is the rocket we're building? Which is, we think NEBRA UPA can be used to building a greater primitive we call the shared settlement layer. So what is the shared settlement layer and how we're going to using NEBRA UPA to build that? So the shared settlement layer is an idea actually originally from Vitalik. He wrote many times, and in his like a proof singularity talks, he actually hinted we should using proof aggregation to solve the interoperability problem among different Ethereum L2s. And really, the problem we're trying to solve here using the shared settlement layer is a silo problem of blockchains. In our view, the layer 2 movement is a great movement to solve a lot of issues. For example, previously, if we want to scale blockchain, we just build another blockchain. For example, after Ethereum, there are many people trying to build so-called Ethereum killers, like Avalanche, like Solana, and many others, right? But these more blockchains only cause more frictions and more silos. And also, you might say, hey, what about bridges? But literally, among all the crypto activities, bridges is the one that raises my cortisol levels most, right? I always become nervous when I try to do any bridge transactions. So the L2 movement is great. The L2 movement partially solve the frictions of the blockchain silos. So now basically what L2 gives you is that L2 gives you a native L1 to L2 bridges. But this is still the partially solve the problem because for any other kind of bridges, even among L1 and L2s and between different L2s, there's still kind of a security issues of like a not native L1 security. For example, let's say if you do a bridge between optimistic L2s to a ZK L2s, right? Most people still are gonna choosing to using a multi-sig based message passing bridges. So this is basically still give you not just L2 security. It's kind of even worse. The worst case is that you need to getting the multi-sig security. So to solve the problem, so we propose using NEBRA to building the shared settlement layer. So again, the idea is really getting from from Vitalik's blog post about 2 years ago. But the general idea here is that we propose the idea called co-settlement, which is a single proof, multiple settlement. So you can see this is actually, if you're familiar with Polygon egg layer, this is one step further compared with egg layer, because egg layer is a one-way settlement. You only settle aggregated proof and settle proof on Ethereum layer 1. So our proposal here is that NEBRA UPA, you can think of the shared mempool. So after we aggregate all the proofs from different kind of ZK rollup or even using ZK fraud proof. So for all these validity proofs, when you aggregate it using NEBRA UPA, instead of settling purely on Ethereum L1, we also make it settle on different layer 2s, ZK layer 2 specifically. So what this gives you is that you get a trustless read from other layer 2s, state root, newer state root, from other L2s. So, and essentially working together with the message passing bridges. So this gives you asynchronous composability and carryback proof. And you can even plug and play with the shared sequencing layer to give you synchronous composability or atomic composability by a few other people. And this is still kind of a work in progress, but we are very excited to review further details in the few weeks to come. So that's conclude my talk. So today I shared with you what we're building. The first is NEBRA UPA, and second is NEBRA shared settlement layer. And just plugging a small advertisement, we're hiring in both backend infra engineer, protocol engineer, and cryptographic engineer. I just want to say this is a teamwork from this amazing team. I'm very fortunate to work with a great team to work on NEBRA and bring the future shared settlement layer to the space.